The first section we're going to cover when discussing probability is theoretical and experimental probability. This is 13.6 out of the pre-algebra textbook. So by the end of this lesson, you'll be able to find the probability of a simple event and also predict the actions of a larger group. So let's write down a few vocabulary terms. First are outcomes, and these are the results of an event. And a simple event is one outcome or a series of outcomes. Probability is basically the chances of an event occurring, and it's a ratio that compares the number of favorable outcomes to the number of possible outcomes. And it's written with a capital P, as you can see here, and then in parentheses is the event or what you're wanting to happen. So for example, if you were flipping a coin and you were trying to find the probability of it landing on a head, you would put P and then in parentheses heads. So the ratio for probability is the number of the favorable outcomes, so basically what you're wondering how often something occurs, over the number of possible outcomes. Now what you don't need to write here is anything in the blue box. I'd just like you to watch as I go through it. So the probability of an event is always between 0 and 1, including 1. And so then the closer a probability is to 1, the more likely it is to occur. And 1 is then equivalent to 100%, where 0 is 0%. So if we're down here on the number line at 0 or 0%, we're basically saying something is impossible. If we're all the way on the opposite end on the right-hand side, we're at 1 or 100%, then we're certain it's going to happen. And then something in the middle, 50%, it's just as likely to happen as not to happen. And a good example of 50% would be flipping a coin, since you have two options. So let's find the probability. Let's say we have a bag and it contains 7 pink, 2 white, and 5 blue marbles. A marble is selected without looking, and saying without looking is very similar to saying at random. So there's no bias as to what color you're picking. So we want to find the probability that the marble is pink. So the probability of the marble being pink is found by taking the total number of pink marbles, because that's the outcome we're looking for, total number of pink marbles over the total of all marbles. So then we're simply just doing some counting here. So how many pink marbles are there in the bag? There are 7 out of, how many marbles are there altogether? 7 plus 2 is 9, 9 plus 5 is 14. So we have 7 out of 14. One thing you always want to remember with probability, fractions in general, is we always want to make sure that we reduce our fraction. 7 over 14 reduces, the top and the bottom reduced by 7 to give us 1/2. Another way to say 1/2 is 50%. So you have a 50% chance of selecting a pink marble out of that bag. Here are a couple other definitions or vocabulary terms to write down. Sample space. Sample space is the set of all possible outcomes. Random is how an outcome occurs if each outcome is equally likely. And we're going to look at an example here with both of these vocab terms. So now we have a die being rolled and a coin being tossed, and we want to know what's the probability that you're going to end up with an even number and a heads on the coin. So for this example, what we have to do first is list what all the possible outcomes are. And we start with talking about the die. So when I roll a die, I can roll a 1, a 2, a 3, a 4, a 5, or a 6. And for the purpose of this class, if I don't specify that it's 8-sided or 10-sided, then we're going to assume assume it's a 6-sided die. So the die has 6 sides. Now the coin has a head and a tails. So you could roll a 1 and have heads or tails. The 2 could be rolled and then you could get heads or tails. The 3 could be rolled, giving you heads or tails. A 4 could be rolled, again you could get heads or tails. Same with 5 and 6. So hopefully what you're noticing here is that the total number of possibilities is 12. A 1 with a head, a 1 with a tail. 2 with heads, 2 with tails. 3 with heads, 3 with tails, and so on through 6. So this gives you 12 total outcomes. So when we're finding the probability that we get an even with a heads, and I'm abbreviating a little bit here, we know that the total number of outcomes on the bottom is 12. We need to figure out how many of those outcomes are an even number with a heads. And I'm going to switch here to a highlighter. So with a 2 rolling ahead, there's one outcome. 3 is odd, 4 with a head is an outcome, and 6 with a head is another outcome. So then you can see with the highlighter there, you have 3 possible outcomes that we want, favorable outcomes for us. 2 with a head, 4 with a head, 6 with a head. So that's 3 out of 12 total outcomes. And again, we want to make sure we're reducing our fraction. 3 and 12 are both divisible by 3, so that gives us 1/4, or if you want to put it in a percent, it's 25%. So if you roll a die and you toss a coin, 25% of the time you should have an even number showing on the die as well as a heads on the coin. Theoretical probability and experimental probability, which is what the lesson's titled. Theoretical is what should occur. So when you flip a coin, you should have half of it land on heads and half of them land on tails. However, we know that through an experiment, that might not exactly happen every time. So the experimental probability is what actually occurs in your experiment. And we're going to look at an example next. So here we have a table showing the results of an experiment in which a die was rolled. Again, we're assuming it's a 6-sided die. And we want to find the experimental probability of rolling a 6 for this experiment. So the experimental probability means what happened over here in this table. So we need 2 things. We need the total number of rolls, and then we need the number of rolls where it landed on a 6. So if we add up here, total number of rolls, let's see, 4 plus 6 is 10, 11, 12, 12 plus 8 is 20, 23, 29. So we have 29 total times that the die was rolled. So here the probability of a 6, and I'm going to put a little e down here because it's the experimental probability, and we look at 6, so it's 6 out of 29. 6 out of 29 times in this experiment the person rolled a 6. Now we want to compare that to the theoretical probability. So the theoretical probability of rolling a 6 is 1 out of 6. That's how often it should occur. And so if we look at these in percents, remember when you're taking a fraction to a percent, you take the top divided by the bottom. 6 divided by 29 is just about 20.7% of the time. So that's how often it occurred in the experiment. If we take 1 and we divide it by 6, we get, if I round, 16.7% of the time. So theoretically, it should have happened about 16.7% of the time. However, in our experiment, it happened 20.7% of the time. And you'll see that happen often, that what you theorize or what you think is going to happen, it's probably close to that, but it's not going to be exactly that every single time. Finally, we want to be able to look at a small sample and then apply that to a larger sample. So we have a graph over on the right that shows a survey of 100 teens, the results. They were ages 13 to 19, and they were asked what they would be doing if they were not online. So you can see they're basically hobbies other than the internet. 25% of 100 teens say they watch TV if they're not on the internet. 26% say they're listening to music. 27% say they are doing some sort of physical activity or sports. 9% reading, 5% drawing, and 8% they've put in the other category. So now we're going to take that idea and predict now what would happen or what the results would be of a much larger group, and now we have 450 teens. So we have 100 teens. How many of those listening to music? Well, out of 100 teens, we have 26%, or you know that to be 26 out of 100. So they've made it easy there to understand. If it's 26% and it's 100 teens, then it's 26 teens out of 100 that say they listen to music if they're not online. So now the question for us is, well, how many teens out of 450 would listen to music? Well, if we know it's 26% out of 100, our assumption here, because we're talking about theoretical probability, it's probably true that it would also be 26% of 450 teens. So now that's what we have to figure out. What is 26% of 450? And to solve this problem, we change 26 to a decimal by moving 2 places to the left. So you're taking 0.26 and you are multiplying it by 450. So you need a calculator for this. 0.26 times 450, that's 117. So roughly 117 teens out of 450 would also say that they listen to music. And again, it's theoretical. It doesn't mean it has to be exactly 117. If you surveyed 450 teens at our middle school that are ages 13 to 19, maybe it's 120, maybe it's 130, but you know, it's probability, so that's what you're expecting it to be close to. It doesn't have to be exactly that. So we were able to find the probability of simple events, those were the first 3 examples, and then also predict the actions of a larger group, which is the final example 4. In class, we'll work on worksheet 13.6.